Hey, good morning. So, this stream I'm continuing my work on the betting research project. Let me center my camera. All right, that looks good. Um, so this is what we've got. Um, this actually isn't what we've got. So that we that shows how much money you would make if that were your region. So let's go to analyses and see what we've done. So yesterday at the end of the stream, I was able to optimize. I did it for each year. Excuse me. For each year in our data set, I optimized a region on all of the previous years. And I did it for each year except for 2007 because 2007 is the first year and we don't have any data prior to 2007 to train on. So we trained to find the best area to put this region in for every year before the year and then tested it on that season. The results for that are here. On the y-axis is how much you would have profited if you had bet $10 on each bet. And the x-axis is the year that you're betting on. And you could see that it's not always positive, but it does tend to be positive. Um, Here's the first run I did right here. And if we remove the first year, 2008, it's just training on 2007 data, so it kind of makes sense that that doesn't return positive. Um, so if we remove that, we see that it does tend to win. This year, there's 14 seasons, and it only lost money on 4 of them. One, two, on 5 of them, and this one it only lost money on 4 of them. And then the other thing is that we see that it actually optimizes to different regions um, for each. And then this is using this is using the differential evolution algorithm with a population size of 10, which is the default in the SciPy package. So I increased the population size to 100 and still got about the same results as the second run from yesterday. So um, increasing population size makes it take a lot longer, but it doesn't really do anything better. Um, now, so that's basically where we left off yesterday. Now, when I was looking this morning before starting this stream, I noticed that this function optimize line location, which is obviously I'm using to optimize, I'm returning this value best x int. And here I had written best x int is equal to data.profit.max. Um, but so plot is equal to true. So basically the problem is that it was optimizing to an x int, but then the value that we're returning where we think we're looking at the x int, we're actually looking at the max profit. Um, so yeah, so we could look at that by looking at the optimizations we did yesterday. The plotting happens here after we define that value best x int. So if it's the wrong value, then it should show up in the optimizations that we did yesterday. So we could go look at those. No, that looks like it got the right value. So let's just put the debugger in here and say, okay, let's go put it in there and then look at the middle. So we want to test the optimization, test region profit, test optimization. So take that test off, put this test on. I have to remember to look at the chat so I don't forget. Let's make this window smaller. Okay. Um, okay, so then in test optimization, we're just saying optimize line location. We want to get it for all of those years and plot it. But our debugger will be entered in the middle, and then we could mess around with it. Or I guess the debugger will be entered after the optimization finishes. So let's wait for this to finish. Okay, now we have our debugger. Now we say, hey, let's go look at max profit. What is max profit? 113.17. No, yeah, okay, so then what's best? X int. Aha. So am I saving where I'm saying profit? Am I mixing up? So here I say write X int profit. Here write X int profit. Profit equals analysis dot assess X int. So X int is equal to nan. Now let's say data. What's the data look like? Okay, so data dot where data dot profit is equal to data dot profit dot max and drop NA. Aha. So I mean that makes sense because the region is finite. So actually we get a range that it could be in. Um, so I guess we could say we could get that value and then we could average over it. So let's say dot x int dot max, and then what's that look like? And then the min. So between minus 194 and minus 203. So we could say dot x int. So we could just take the mean of it and say that that's the x-intercept. And then here, yeah, so okay, good. So I guess I didn't explain this very well. Before I started the stream, I found that problem. I rewrote xint here, best xint, to be this. And then I ran that optimization with a pop size of 100. The problem is this returns a nan. So instead of getting that value, we want to get the value we just typed. So best xint is equal to data.where data.profit is equal to data.profit.max. So we want to get the max profit. This gets all of the max profits, drop everything that's in nan. So now we just have basically this array right here. And then we want to say, so wait, where are we? Okay, so we've dropped it. Then we want to say get the xint column and then get the mean of it. Or we don't want the mean of xint. We want the median because it's differential evolution, so it hones in on a final value. So it honed in on minus 198. median or the mode. I mean, I guess the mean is fine for now. Um, but so here's what was happening before is we were saying whatever the best x int is whatever the profit is. So instead of minus 198, which it actually found, it says that the best x int, oh, max profit. So instead of minus 198, it's using 113 as the intercept. So it's actually getting a much smaller region than we want. So instead of that, now it should be returning this best x int. Now let's take this out. Make sure it's the same thing. Yep. Okay, so we can save this. Hit continue on here. And now let's run it again. Before we run it, let's take the optimization test off. Let's do perform optimization analysis. Yeah, so now we're going to do the optimization analysis with a pop size equal to 10. Yep, pop size is 10. And then, so I want to see, I'm pretty sure what was happening here is we're actually, we're testing on the test, or sorry, we're training on the training data set. And then the training data set gets an x-intercept and a profit that corresponds with using that x-intercept to bound our region. But then when we're testing it on the subsequent season, we are testing it with the profit as the x-intercept instead of the x-intercept that we found. So we get some negative values. So now let's run this, and my hope is that we're going to end up with some positive values. But we're still getting an error associated with the polygon class. Something about finding points in the polygon. We could see that error here. Here, I'll show it to you. Time warning invalid value encountered contains so it's in the Shapely library. Predicates. Yeah. We could go check that out as that continues to run. Yeah, you can see I was already looking at it here. Pull that back up so we see when it finishes. Pull up the chat. That's still running. Wonder where it's at. The last one it did. Oh yeah, so we also want to change the plots so that they look nicer. So let's go to our Trello board. Oh, wrong one. Okay, so we want to be here. Change output to be in terms of percent return. So I'm going to do that today. Get optimization to consistently give the same results. I'm going to work on that today. And also brainstorming ways to tweak analysis. And then the other thing I want to do today, what was that I want? Oh yeah, fix plotting so that the saved plots look good. And we're going to do that by set aspect ratio. Okay. And that is, we'll say it's also high priority just because we're doing it today. I can't believe this is still running. What year are we on now? Okay, now it's up to 29. Okay, so we should be close to done because we can't see what year it goes up to. That's why we need to fix the plotting, or one of the reasons we need to fix the plotting. Good. No such file or directory. What? Oh, that pasted the second one in. Okay, so that ran properly. Now let's open Python. That's just the runtime error that I copied in, and then when I copied it, it automatically pasted it. So this finished running, then we got here, and then it pasted that in here, and then it gave us an error. So it works. We could go into Python, import pandas, or from pandas, import read CSV. Let's read the file. Okay, so it does better, but it struggles on more recent years. Okay, new slide. Was using the wrong output with the correct output. Okay, so that's interesting. So that does well until it gets to more recent years. Starts struggling in 2017. So it could be that this trend. Okay, let's just put it in first and then we could take notes on it. Damn it, how do we move this? There we go. All right. So, all right, now that's with the correct output. Performs well on early seasons, begins to struggle in 2017. Okay, so it begins to struggle in 2017. Now, before the assumption that we were making, oops, let's put that there. So before the assumption we were making, if you remembered, I mentioned that okay, so 2008 it performs poorly because it didn't have any data, or it only had one season of data to train on before that. Now we have a totally different trend, which is that, hey, without much data, it actually performs okay, not optimally, not, 3 isn't the biggest amount, but it performs well. But then later seasons, when we have a lot of data we're training on, in the last 1, 2, 3, 4, 5, suddenly we have 3 negative seasons. So this looks like the opposite problem. Instead of we get negative when there's not enough data to train on, now we're getting negative when there's too much data to train on. And what might be happening is when we're betting on 2020 games, we don't want to be training on data from 2007. That's too much information. We want to be able to train on just the previous few years. So let's go down here. Perform optimization. So now this does all years is that for year and all years training seasons equals np.arange. So we want to do from year minus 3 to year. And then what will that look like? So if we say year equals 2009, 2013, then we're going to do np.arange from year -3 to year dot to list. Oh, right, import numpy as np. Now let's do that. Damn it, we'll just say year is equal to y. Okay, so 2010, so if year is 2013, okay, so that's the right way to get the previous 3 years. So perform optimizations, num years to train on. Default is all. And then we could say if num years to train on is equal to all, then, okay, here we could say min year is equal to 2007 if num years to train on is equal to all. Else, num years to train on. If num years to train on equals all. Else, min year is year minus num years to train on. Um, okay. Okay, so now we have min year. Now the problem is if the year is 2008, then, okay, so the all years, okay, so for year in all years, min year equals 2007 if num years to train on is equal to all, else year it else min year is year minus num years to train on, and then we could say min year is min year is equal to 2007 if min year is less than 2000. So if it's less than 2007, make it 2007. Otherwise, just let it be whatever it is. All right, now does that make sense? All right, let's move this over, see how we wrote that code. So let's say m is equal to, so let's say it equals to 2006. Now we could say m is equal to 2007 if m is less than 2007, else m. Now m is 2007. So if we make m 2009, then do that. Then what's m look like? Nice. So if it's less than 2007, reset it to be 2007. Training seasons equals year minus. Oh, so it just goes from min year to year. Okay, then test seasons is equal to year, x int equals optimized line location. Okay. Now, let's exit out of here and run the analysis again, but it takes so long. Let's try making, oh, I want to try making our pop size 5 because that would improve things so much. Or it would improve speed so much, but I'm afraid that that won't return good results, but let's test it. Oh yeah, num years to train on. Perform optimizations, num years to train on. Oh, is equal to 3. Okay, now let's run that, and I'm gonna go to the bathroom real quick. All right, so oops. All right, so I'm gonna go make sure the mic works because it didn't work last time. Cool. Then it's working. So we just did the optimization. Now let's go look at it. Import from pandas. Okay, so it performs worse. Performs worse only looking back 3 years. Let me put my sweatshirt on real quick. Okay, so obviously this new one did worse. First one we didn't lose money until 2017. Got hammered in 2018. So I guess maybe there's just something that changed. The strategy became more difficult to use around then. So the other thing I'm thinking about is maybe we could use a more complicated line, um, or a more complicated region. Now this region, all right, now we should pass in. So we're gonna want to define different regions. So let's pass in region type, and then let's add a function here, test region type, and region type should be string, and then we're just gonna say valid region types is equal to so what should we call that first one? We need a clever name. What to call it? So triangle, I guess. Okay, and then let's describe the region types here. Triangle, defined by 2 lines. Okay, so the first line is y is equal to minus x minus 22.222 repeating. And we're going to note that minus 22.2222 correlates with the odds offset for sports books to win at 55% rate. Now the second equation is y is equal to x int closing parentheses on the end there. So the second equation is y equals x int defined by 2 lines and associated points. So y is equal to x int. X int is the variable parameter. And then point 1 should be the, let's put it, um, nice. Okay. Now what should be the next type of if region type not invalid region types raise exception region type not valid must please specify valid region must be one of valid region types. Okay, so now the second region type, what do we call it? Narrow cylinder. Okay, the narrow cylinder is defined by two lines. Both with both extended to plus slash minus 10,000. Okay, and then line 1 is y is equal to minus x plus a, where a is first free parameter. And then the second line is y is equal to minus x plus b, where b is the free second parameter. Okay, so let's add this in here. Narrow cylinder. Okay. Now, point 1. What should that look like? Point 1 should just be x. Point 1 should just be first line extended to minus 10,000. That should be 10,000. So point 1 is first line extended to minus 10,000. Point 2 is second line extended to minus 10,000. And the other points are just these same things. All right, so take out the minus. And then this is just 3 and 4. Um, Now while we're changing this around, we may as well try with a different number of years to train on. So test years to train on is equal to 1. Um, let's just make that 0 for now. And let's try training on 5 years, going back 5 years. Oh yeah, so if we look at this, if we look at our two values, here's what we have. Now the first year, on the first one we ran, the first year that lost was 2017. So that had 16, 15, 14, 13, 12, 11, 10, 9, 8, 7. 10 years of training data. So maybe 10's too much, but 3's too little. Um, let's try with 7 years of training data. Then we can run that. Oh, we're going to want to put our value in. So was that the one we had up? No, this is with it corrected. Does limiting the number of years of training data help? Okay, so that is the one we already have. Let's check one more time to make sure it's the same. Minus 9, minus 4, minus 11. Okay, so we have that. Now let's go get this one. Three training seasons. Gives that result. Just running. All right, so let's run it. Make sure that extra test we added is off. Perform optimization analysis. Cool. So let's run it. Now, perform optimizations. Oh, so the type should be string and it should be equal to all. Huh. This shouldn't be string actually. This should set it default equal to all. Now, why did that start happening? Back to that bounds problem we were having yesterday. Bounds for the x-intercept. Yeah, what changed? Num years to go back is equal to 3. Did I change anything? Assess x int. All right. Um, so we changed something that stopped it from working. Pull that back up so we don't miss any chats. Um, okay, so we're gonna copy that because we might get rid of it. Oh no, we don't want that. We want Notepad. Okay, now does this work? Nope, that doesn't work. I don't know what I changed that would have broken it. So here I'm just going back, kind of removing the stuff that I did. I already pasted this function in so we won't lose it. This is honestly just baffling. I don't know what the issue could be. Get region. Aha. That might be it. Yep. Okay, so let's stop this from running. Now, let's go down here, change this to 7, and let's run it again. Okay, now we want to go back up here, put that back in, plot region, get region, and then we want to add in region type, string, and the default is triangle. And then we can say test region type. Okay. All right, got a nice function there. Now we're gonna do test region type of region type, test region type of region type. Okay, so we're gonna test that to make sure it's valid. Um, then we're gonna say if region type is equal to triangle, and then we're gonna define the triangle region. Okay, Now if region type is equal to polygon, then region shape is equal to that. Sorry, if region type equals to triangle, and then we want to return region shape. Region shape. All right, now we can say elif region type is equal to narrow cylinder. Let's actually just change that to be rectangle, because narrow cylinder is confusing. Right? Change this to be called a rectangle. Our analysis now get region params should be a dict. Then for key in region params dot keys, if x int is not one of our keys, if we could just say if x int not in region params dot keys. So if we don't have that parameter in there, raise exception. X int must be a specified parameter for xint must be a specified parameter for the triangle region type. All right, then we could say else x int is equal to params of x int. Now let's go see how training on 7 years did for us. While it removed, we're still losing in 2017 and 2018, but we're doing better in more recent years. Oops. All right, now here I'm just gonna say region type is equal to triangle. And then we won't have to specify that. And actually, we don't need to specify the whole thing. We'll just say self x int and then close it off and we're good. And then we'll say params is equal to a dictionary x int, and we put in x int region params. All right, now this should be region params as well. I think that should work. Now, um, test training years is equal to 1. Take the perform optimization off. Now, if test training years, so if we want to test what the number of training years to use is equal to true, then we want to say num years is equal to np.arange, and we want to get years, import numpy as np, np.arange 10. Okay, so arange 1 to 10. And then what's the max years we could go back? Uh, we could go back to up to 10 years, I guess. We could say 12 years. Yeah, let's test it on 1 to 11. So using a maximum of 10 years. Num years equals np.arange 1 to 11. All right, so we have the number of years we want to, all right, now for year in num years, perform optimization. Num years to train on is equal to year. Perform optimizations. Then we want to open up that CSV file. So we're going to say A equals R, and we want to read CSV, analysis 1, trend 3 / test all results.csv. So we're going to read that and then save that. If not os.path.exists, analysis 1, trend 3 / so if we don't, what do we want to call this directory? Test all results, triangle years to train test. Os dot make directory, and the directory is just this, what we just typed. So make that folder if it doesn't exist. Now we're going to say a dot to CSV, and we're going to want to save it to analysis 1, trend 3 / triangle years to train test, triangle years to train test / year.csv. So now this should go through and save the results for us, and it'll run it for each year between 1 year to train on and 10 years to train on. So just making sure the booleans are right. Now, are we good to run this? Analysis 1, trend 3. Okay, we should be good. And then this should run in the background. Define get region. Forgot the colon. Get region. Okay. elif region type is equal to rectangle. Pass. Okay, now that should run. Okay, cool. So while that runs, I'm gonna go code in how to do a different region, and then we could test that other region. Right now, it's looking at for if we change the number of years back that we train, do the results differ? Can we, by selecting how many years of data we train on, can we get a pattern that's successful? I'm gonna go to the bathroom real quick, then I'll get to the coding part. All right, so I just realized I might have called my live stream the wrong thing. So I'm gonna go see if I could change that real quick. It says this stream is going slowly. All right, don't know what to do about that. I pay for expensive internet, so um, today is not 12:12, it's 12:13. All right. So, um, let's pick up where we left off. So what are we doing? What are we doing? All right, we want to write new code for the different region types. Oh, damn it. Um, analysis 1.py, perform optimizations. In perform optimizations, it's getting the x int equals optimized line location. In there, it's, oh man, it's in differential evolution. 205 and assess x intercept. 205. Bet return referenced before assignment. For item and region wins, if np.isNan of item.any, so if there's no nan values, then get the bet return. If there are nan values, np.isNan of item.any. Okay, then let's just say else bring in the debugger. So if we're getting nan values, I want to go check that out because I don't really understand what's going wrong there. So we've got that. Now that's free to run. Back to get region. So we have region params, and then we have region type. So if region type is equal to triangle, otherwise if region type is equal to rectangle, let's just do region params. Man, this is just a pain in the ass. Xint. Got a phone notification. Offer up. Let's put the chat back here. Don't want to miss any chats. So we want to get the region, we specify the params. So if region type is equal to rectangle, necessary params is equal to A and B. Now if for param in necessary params, if param not in region params, raise exception, strategy, raise exception saying rectangle region must contain params and then necessary params. Param not in region params, not regions params. If param not in region params, raise an exception. Now, assuming we do have the parameters we want, point. Now, let's think about it. So we have these two lines, and they're both extended to x equals plus minus 10,000. So point 1 is equal to the first line. So the first line is A, is defined by A. So point 1 is equal to, all right, there's 2 points. Now the x point for point A is easy, it's minus 10,000. And the y point is whatever y equals minus x plus a. A for the first one, right? Yep. So minus x plus a minus 10,000 plus a is equals y. Point 1 is minus 10,000, so that's the x. Oh, so that should be positive 10,000 plus a. Point 2 is equal to, all right, so point 2 just extended out to positive 10,000, so 10,000, and then minus 10,000 because the slope is negative, plus A. 0.3 is equal to, and that's the same thing. This is actually simpler than the last region definition. So 0.3, copy that whole thing. Instead of A, that should be B. Do we say A equals something? Oh, necessary params. Oh, region params of A plus region params of A. Region params of B and region params of B, and then change these points to be 0.3 and 0.4. And then define that down here, polygon of region points, and then here we say region points is equal to 0.1, 0.2, 0.3, and 0.4. So those are our region points. Copy that, put the same thing up above for the triangle method. All right. We have the region points. Let's go see how this is doing. Didn't mean to open that. Quit. All right, now analysis 1, trend 3, triangle, years to train test. Okay, so 1, 2, 3, and 4. How does it do? So in 1 year to train, it only returns negative twice. 2 years to train, it returns negative 1, 2, 3 times. 3 years to train, it turns negative 4 times. And 4 years to train, it returned no money for 2020, huh? So it doesn't seem like it's really improving as we increase with more years to train. 5 years to train does okay, and 2 negative. Seems almost sort of random. And just training on the previous season might be best of all. 2021 trained on 2020 data would have returned $115. Now that's surprising. Right, so we still need to change it so it's in terms of percent return, but let's keep changing our region. So we have a region defined here, so I think region type, region params. So I think we should be able to put that in now. Now get region, where do we call that? Only called it twice. So it's called in plot region and it's called in assess x-intercept. Okay, so we're gonna have to write this down because this might be a little hard to follow. Where, there we go. All right, so back to this document. What we're going to want to do, so back to, okay, so we've changed get, all right, so the first thing we did is we changed get region to read in region params and changed, we could say this change is basically generalizing. So we generalized get region to get region params and region type. To read in region params and region type. Now we need to change input wherever get region is called. Now, where is get region called? It's called in plot region. And assess x-intercept. Assess x-intercept. So we want to add params to plot region. I have to sit up. All right, now we want to add these params to plot region, and our question becomes, where is plot region called? Okay, let's go look for it. All right, it's called inside of optimize line location. Optimize line location. Optimize line location. All right, and the other place it's called is in test region plot loop. Okay, and anywhere else? Plot region is the third reference. Oh, and in test region profit. Test region profit loop. Test region profit doesn't call anything. All right, so optimize line location. Now, add params here. Where is it called? All right, optimize line location. It's called in perform optimizations. And then all right, it's called in perform optimizations. And where else? One other place in test optimization. Test optimization. And then that add params. Now where's it called? Perform optimizations. It's called in perform optimization analysis loop, and also test training years loop. All right, so that's all the stuff we have to update just for updating get region. Now we need to update assess x int. Need to update that in optimize line location. Okay, so reference where, and we're gonna want to add the params, of course. Okay, now assess xint, where are we referencing it? We're referencing it in optimize line location. All right. Where else? Perform optimizations. Right, perform optimizations and test region profit. Test region profit loop. So our procedure will be one update. Oh, okay, so we can make this wider. All right, so what will our steps be? Number one thing we want to do, generalized get region to read in region params and region type, need to change input. So change input to assess x int to allow for different region types. Okay. The second thing we want to do is all right, change input to assess xint, change name of assess xint to be more general. Okay. Need generalized region to generalized get region. Okay. Then need to change input. So first it's called in plot region, then it's changed in assess xint. Now need to all right, not need to, just say update assess xint inside of optimize line location. All right. Now for we want to update assess xint inside of perform optimizations. 5, we want to look at it or update it inside the test region profit loop. Then we want to say update plot region. To pass in params for different region types. Update plot region, then update plot region in optimize line location. Update plot region in plot region called there, and then test region plot loop. And then we want to update plot region in test region profit loop. And then for updating in optimized line location, update. So then we want to update optimize line location to update optimize line location to allow for general shapes. Then 11 is update optimize line location input to allow for general shapes. Okay, then 11. So once we have that, add the params, and then that's called update perform optimizations. Okay, so update perform optimizations. Update optimize line location in perform optimizations. In perform optimizations, then update params in perform optimizations. So then update params in perform optimizations to allow for any shape. Then now this is a big pain in the butt, but once we finish this, then we'll be able to add any new region shape easily. Let's see how this is doing. Oh, we got more views. No chats yet, but we did better with views. All right, now pull that up. All right, so then we want to update the params in perform optimizations to allow for any shape. Then update perform optimizations in perform optimization analysis loop. And the last thing is update perform optimizations in the test training years loop. All right, so we've generalized this, so now we can add, once we do this stuff, we can add any region we want without updating all this again. Next time we want to add a region, we just have to change, next time we want to add a region, we have to change this get region. We just update it to say if region type equals whatever the new name of our region is, and then we need to update this test function so that the new name is invalid tests. And we don't need to worry about any of this. So we'll do this once and then we'll be done with it. Now, this optimization has finished. So we looked at all of them through 5. Let's look at the higher number of training years. Yeah, so this just consistently loses in the more recent years, other than this one. So if we train on the previous 6 years, it works. If we train on the previous 7 years, it doesn't. For 2019 through 2021. So 2020 is a loss every year, except when we trained on the previous 6, it worked. If we train on the previous 5, it works. If we train on the previous 4, it does nothing. Train on the previous 3, it's negative. Man, that's weird. So there's not a pattern we can discern from here. Oops, cancel, don't want to exit out of there. All right, so let's go do everything that's on our to-dos. So, number 1, change input to assess accent to allow for different region types. Now, okay, good, we added in that to get regions. So, change input to assess accent. Oops. assess x int. So it passes in x int and seasons. Instead of that, we want to pass in region params and type instead of x int. Region params, region type. Okay, update input to assess x int. Change name of assess x int to be more general, so assess region. Change name of assess x int to be more general. And then I didn't write it. I didn't write it down on the to-dos, but we need to fix this because that says x int. So region equals self.getRegion. And getRegion passes in region params and region type. So let's just do that. Region params region type. Okay. Wins. Okay, so nothing else is broken in there. So we can say that this is done. Now update assess x int inside of optimize line location. Optimize line location. Assess x int. So now we want to do, instead of x int, we want to assess region params and region. What are the things we're passing in? Region params and region type. Region type. All right, so we've updated assess x int inside of optimize line location. And then do it inside of perform optimizations. So done with that. Perform optimizations, x int should be region params, region type. And we could just copy that because I keep changing that. So that's good now. Perform optimizations, update assess x int inside of perform optimizations. Done. Test region profit loop. Test region profit. Separate data, test seasons, assess x int. Then we could just say that region params, region type, and then region params is equal to a dictionary where the first key is x int and the value is test x int, and the region type is triangle. Okay. Done with that. Now we want to update plot region to pass in params for different region types. So let's go to plot region. Do we update assess x int in here? Assess region should be called in there. Oh no, it's not. Assess x int. Oh, update plot region. Update assess x int. Oh. So instead of assess x int, this now should just be assess region. Now let's get the other assess x int becomes, oops. assess region. And this also becomes assess region. Okay, done with that. Now update plot region to pass in params. Bounding box is equal to self.getRegion of xint of update plot region to pass in params. So not xint. Want to get region of that, and then region params, region type. Region params, region type. Okay. So we've updated plot region, update plot region and optimize line location. Or we could just find plot region. Xint equals best xint. Region params equal region params. Region type is equal to region type. Actually, we could change we kind of got sidetracked here. So this, really what we're doing is, last stream I optimized region definition. It doesn't make money every year, so I am tweaking the optimization in hopes it will turn positive. I am also generalizing the code to optimize for different region definitions. Okay. All right, so back to our to-dos. So we've updated plot region to pass in params. Now we need to update plot region everywhere where it's called. Region params equals region params, region type equals region type. So we've updated it there. Now let's go find where plot region is called elsewhere. Plot region. Okay, so plot underscore region. Back to the top, plot region, fixed that, fixed this. Now we need to fix here. So plot region, seasons equals, so plot region, what's it take as default? Xint seasons. Okay, so we want to take out xint. And take out xint there. Oh man, that's going to be a big pain in the butt to update the xint stuff in there. Okay, so update plot region and test region loop. Oh yeah, we had to take that xint out. That was an optimized line location. Now here, put that there, then we could say region params equal region params. Region type is equal to region type. Now, what was it before? Xint equals something? Oh, where are we? Okay, we need to take that out. Okay, so x int equals 100. Now region params is equal to x int, and the value is 100. Now we can take that out and say what we just had. Region params is equal to region params, region type is equal to region type. Okay. Now we need to remove the x int here and then remove it also in the function definition. Okay, we've taken that out. Update plot region in test region loop, test region plot loop. Okay, updated that there. Now, done with that. Update plot region in test region profit loop. Test region profit plot region. Okay, then we're gonna say region params equals region params, region type equals region type. Region params is a dictionary with the x int is equal to test x int. And then region type is equal to triangle. Damn, I already added that in there. Okay, test region profit loop, so that one's done. Now update optimize line location input. Optimize line location input to allow for general shapes. So we don't want to pass in region line, but we do want to pass in region type. And it should default to triangle. And then do we call region type in here? Nice. Optimize line location, pass in region type. Okay. Okay, so we've changed the input to optimize line location, but now we need to let's stop here and fix here. So optimizable func. What are the params we want to pass in? So if we could just pass in any params, and then we could say assess region. So region params is equal to params, and then region type should be equal to region type. Region type is equal to region type. And then seasons is seasons. What's seasons? Nice, so the past and seasons. So that's our optimizable function. Now we need to rewrite the params. So if region type is equal to triangle, then region params is equal to x int and the value we're putting in is params of 0. Okay. Then we can say elif region type is equal to rectangle. Then we could say the region params are equal to A, and A is params of 0, and B is params of 1. Okay, then we have region params. Then with open file name right, line string is equal to params. Okay, so I'm just gonna play around in the terminal to figure out how to write this real quick. So we're gonna say RP for region params is A, 1, and B is 2. Now for so let's figure out how to write this line in one line. We're gonna say I for I in rp.keys will give us A and B. Then we could say get us rp of I for I. And then we're gonna make this a function string. And we're gonna say p of I. What's it? Oh yeah, p of I comma space. Function, oh. Alright, then dot join. Okay, so I did the join syntax backwards, but it should be just join with no character, join that all together. Okay, so line string equals f do dot join, and we want to join the list of, so we're gonna get function of region params of I. Oh, and then do a comma space, and then for I in rp dot keys in region params dot keys. Okay, then that gets us that. Then we're gonna want to add plus string whatever the profit is. Okay. Now what the hell's the region type equals region type? Assess region. Seasons equals seasons. Okay. All right. So we've got our line string, then f dot right. Um, yeah. Oh, let's just put the \n at the end here. Then we could just say write whatever the line string is. All right. So we've fixed that. Now we want to say, now we want to fix this with open f dot write. So here we want to write I for I comma space for I. All right. We don't want the last comma on there. So you could get rid of that and join with a comma space. Nice. Now where's that? F dot write with open. No, not there. Open file name. X int profit. So instead we want to write dot join I for I and rp dot keys. Not rp in oh. All right, f dot write. No. Ah. So we're gonna have to update this every time. Test region type, valid region types. All right, so let's just put valid region types here. I'm gonna make it a dictionary. The first one is triangle, and the only properties are x-intercept. The second one is rectangle, and the properties are A and B. Triangle, that should be list A and B is what it has. Valid region type, so test region type, so if region type not in valid region types dot keys, then do that. Then down in optimize line location, for the beginning of this, we can say, so that whole mess, we can just say, put in there valid region types of region type. Okay, then it'll write the keys in there. Oh. Valid region types of valid region types. Okay, so then we'll just say params is equal to that. Params is equal to that. Then we can say for, I guess we just want to join it. Params is equal to that. Then in here, we'll just do that, comma space, dot join. And we want to join params. So that fixed that. Now, if region type is equal to triangle, okay, so for param in params, first we're going to get region params is equal to a blank dictionary, then for param in params, region params of, so let's enumerate the params. And then for C, so we're going to count each param, then region params of valid region types of region type of C is equal to params of C. And then this, I think we can comment out. Let's see. Now that should make things nice and much more general for us. Meaning that we only have to update this valid region types up at the top. Okay, I think that should work. Yeah. Okay, so we finished with that one. Update optimize line location to allow for general shapes. So I think we've finished updating this. Oh, but we have to update the plotting. So yeah, we need a different plot for each. So this gives the arrangement. So if we want to plot each parameter on our output plot, what do we do? Oh man, so it plots the region. It'll do the right thing. We just got to figure out this subplots part. Man, this is a big pain in the butt. I'm kind of stuck on thinking how to do this. And I'm out of coffee. Gonna pull this up so I don't miss anything. Oh, Barcote. Hi, Barcote. Hope you're doing well. Hope you're still watching if you're there. Thanks for watching. I'm updating my strategy now. Here, I'll just show you where we're at. This will take 30 seconds. So last stream I left off, we had optimized wherever this line is. The blue line that goes up along here is constant, and we're basically defining the region off where this vertical line is. And we did a differential evolution optimization to get where that line is. And then for every season from 2007 through, or sorry, 2008 through 2021, we trained it on the previous seasons and then tested it on the subsequent season. These were the results of the test yesterday. This morning I found a bug where I was testing actually the wrong value. I fixed that bug and we got slightly better results, but it's still giving negative values for more recent years. Um, and then I tried limiting the number of years of training data. And I actually earlier in the stream I did it for between using 1 year to 10 years of training data. But we still see that basically no matter what, it's losing money for more recent years. So I thought, I'm not sure what to try with that first region. Now I'm going to try a second region definition, and that's what I'm adding in now in the code. So now instead of just region type being the first region, which I'm calling triangle, now we could pass in a second region type. And then once I update this code, to pass in any region type, then any new region we want to add will be really easy to add. We just need to change a few lines and instead of changing everything like we are now. So, um, what I'm trying to figure out now is, um, well, we're in the middle of updating. Where was I? So we finished update, optimize line location. Now we want to update. Oh, right. So this was pretty intensive to change, but I think we finished updating it. This function right here, optimize line location. Now I'm almost done in, oh, so now we need to go into perform optimizations and update how we call it. Oops. Perform optimizations. So num to train on. Now the function we're looking for is this one. So optimize line location. Instead of just taking in the number of seasons, it also takes in plot, show plot. So it should plot, should not show. Those are the defaults. And then region type is equal to triangle. So now this should be pretty easy. We just have to pass in a region type. That should be equals though. Now, region type is equal to, the default should be equal to triangle. And then optimize line location of training seasons. Okay, just a sec. So we want to pass in the region type to optimize line location, but then also optimize line location. I just realized here just spits out the x int. So best x int. So we have max profit. No. Oh, right. We also need to change our bounds. Okay, so we haven't finished updating this function yet. So if region type is equal to triangle, then use these bounds. Otherwise, if the region type is rectangle, we have two parameters, and we're varying the where they're placed. That we're varying basically the y-intercept. So the bounds on our data, I guess, yeah, it should also go from, let's make it minus 1,000 to 1,000. Might as well make it minus 5,000 to 1,000. Minus 5,000 to 5,000, I mean. Minus 5,000 to 5,000, and I guess both of these. So this should be minus 5,000 to 5,000. So otherwise, if it's rectangle, then set those as the bounds. Then we get res data equals pd.read csv of file name max profit equals data.profit.max drop na dot x int dot mean best. Okay, now this is where it gets hard. So okay, best params should just be an empty list. Now best x int equals that. So well, I guess best params would just be this. But we don't want to, oh, we do want to drop it, but we don't want to get that. So now for best param data is equal to that. And then we're going to say we're going to take the average of the best param data. Oh, so for param in data dot keys. So for each parameter in data, if param is not equal to profit, now wait a second, we don't want to, when we want to say optimize line location, okay, we don't want that because then it'll put a space in the names. We want to be able to get the names. So now back, where was I? If param is equal to profit, then we're going to, oh, so if param is not equal to profit is the only time we want to do anything, then best params is equal to should make it a dictionary or a list. Result equals analysis dot assess x int equals that. So now, right, so here we want region params, so it should return params that are the same as the params that we pass into assess x region. So params returned by optimize line location should be in the same format as params passed into assess region. Okay, be right back. Okay, so Now we know what the parameters we want to now we know what we want the parameters to look like. Now we're saying if parameter is not equal to profit, best params of param is equal to, so we've already isolated the best param data, so we just get dot, okay, so is equal to best param data of param, and then get the mean of it. Best params is equal to that. Then we want to return best x int. Season equals seasons. Region params here should be the best params. And then here we want to return best params. Okay. Okay, so we finished with that. Now this result should be in the format of the parameter dictionary. Sorry, this x. Now this x int should be called region params. Now assess region, region params, region type, seasons, region params, region type, test seasons, region params, region type, seasons. Okay, so now we want to update, optimize line location and perform optimizations. Optimize line location. Yep, we passed in the region type, so that's done. Now we want to update params and perform optimizations to allow for any shape, region type. Oh, okay, I already did that. Done with that. Update perform optimizations and perform optimization analysis loop. Region type is equal to triangle. Perform optimizations, region type is equal to triangle. All right, now let's think. Test training years is equal to true. Perform optimizations. So I'm just gonna say region type is equal to triangle. And then also, since we're changing the region type, when we make the metadata file, we want to write that. Now, seasons, and then, oops. Okay, so we're writing that. Then we're gonna say f dot write. Um, let's go for season in seasons. We're gonna write over a tab and then put in the season name. And then, what else do we want to write? So f dot write region type. And the region type is skip a line so it's easier to see. The region type is region type. Nice. So that will be added to the metadata file for our optimization. Update test training years, did it get updated? Yep. So these two are done now. Done. And then we want to test it on optimize line location. So I need to update this in test optimization. Region type is triangle. So now let's test the test optimization. Let's turn on that test and see what it does with this updated code. All right, let's exit out of here. Run it. Okay, so we've already got an issue. Exit not in region params.keys. NumPy array has no attribute keys. 197. So an optimizable function profit equals that. Region params is equal to, optimize line location. So region params is equal to region params. And let's run it. Cool. So that seems to work. I hope it stops before too long. Nope. Data frame object has no attribute. 268. Okay. Data.profit. So the file will be whatever the most recent CSV file is. Now the question is, why is nothing coming up? .csv. What just happened? The only test that's on is test optimization. Now I went and made a CSV file for 1,000,000 optimization. And they all saved at the same time. Now why would that happen? Optimize line location. Now what failed? Data frame has no attribute profit. That's true it doesn't. It's true that doesn't have an attribute profit. Now, I'm trying to figure out why is it doing several optimizations with open file name optimizable func. The file name doesn't change names every time. It looks like it's a real optimization. Let's see, so it goes up to 216 now. If we run it again, what's it do? It only goes up to 217, so that's good. Um, F dot right backslash n and then season. Um, so it's running it, but it's not writing that parameter. So we could say, I'm confused on why it would return the same thing constantly. Or I want to know why it ran so many optimizations. Oh, these aren't all at the same time. Okay, so that's actually not so bad. Now, with open file name params is equal to ah. Um, okay. So params equals that. Now we could say that top line is equal to that plus comma profit. Oh, actually no. Just do that comma profit. Now that should work fine. Oh, I guess there's a lot of optimizations because it's optimizing line for each year. And if we're going back 10 years, it'll just say we're going back 3 years and then we're doing 2011 through 2021. That's 10 years where we're going back 3 years. It does an optimization every time it goes back. Still don't understand how we end up with over 200 optimizations today, but that's okay. Okay, now this should work. Let's test it. Okay, so the question is what to do if this works. Once this works, we can optimize with our different region, and then we could kind of try around whatever region we want. Did I not save this? It's been saved. The value profit. Okay. Now it just skips that line altogether. Okay. Oh, duh. Forgot to write it. All right, so let's write that top line. Save it. Now let's run again. See what it does. Need more coffee. All right, nice. And that works. Man, that sucks. Let's go see what it looks like. Oh, that's the metadata. Oops. No, don't want to do that. What the hell? Nice. Now the big question is how come we don't return a negative profit? I mean, if you're telling me why do we never return a negative profit? That's the big question. Now if we do, well, we know we should return a negative profit. I guess because it's optimizing. Might never return negative because it's optimizing. Um, let's try optimizing for test training years, perform optimization analysis, num years to train on. Let's say let's train it on all. And the region type, now let's say, is rectangle. Now let's go see, we're going to want to perform optimization analysis. Now let's go see what a rectangle does. Test optimization. Yeah, let's do optimization analysis on a rectangle. And then test years. Should be a list, and it should be default equal to np.arange 2008 to 2022. Now for year in test years, now we could get rid of that line. All right. So let's go down here. Num years to train on is equal to all, and we're just gonna say test years is equal to, we want to get 2017, 2018, 2019, 2020, 2021. I want to see how it performs on recent years. All right, now let's run that. That should take a little bit to run. Perform optimizations. Oh, now what's going on here? Rectangle region must contain params A, B. Analysis one. Oh, nice. So what's going wrong? Don't need that for now. Or that. So what's wrong with our rectangle? Rectangle region must contain A and B. So that means A and B aren't being passed in. Perform optimizations. So that's the problem in assess region. In perform optimizations, result equals analysis.assess region of region params. Now, what do those region params look like? And this should fail again in the same way, but we'll be able to look at it. Okay, so region params. Region type, defaults to triangle. We do perform optimizations. region type. Now we said it equals rectangle. So we should be passing in that region type. Return best params equals that. For param in data.keys, if param is not equal to profit, best params of param data equals pd.readcsv. So it's not optimizing with the rectangle. It's not optimizing with the rectangle. That's basically all we know. Okay, so it's 1 p.m. where I am. This means that it is time for lunch. So I'm gonna highlight where this is. I'm basically stuck right now trying to code this. So let's put in a new slide. Stuck on 12/13/2023. Working on code update to allow for general shapes to be tested. And I'm stuck. Optimize. Stuck. And what's this function again? Optimize line location. Line location is optimizing for triangle region when I am trying to work on rectangle region. All right, and then throw that in there. Here's what our error code looks like so we can find where we are. And I'll be back later today to stream again and finish this problem and start looking at other regions. But as for now, this will be the end of this live stream.